So if you grab a torch and shine it like you would as a mirror and reflect it back in your eyes, you see it's not very bright. But when you shine it from the direction of your eyes, you can see it's quite bright right there. And so you can do that. You can grab a piece of material and just grab the torch, and you'll see that it's the brightest when it's coming from the source. So if your eyes are the source, it's coming straight back here and it's nice and bright. And then every other angle, it's not so bright. Okay, so that's the bright, and then that one's not so bright. Okay, which you'd expect to be bright if it was a mirror. Okay, so that's called a retroreflective material. I think it's probably, because it's cheap, it's probably just the plastic one. But the ones on the road are the beads, and it's the ones we're going to look at because they cover more concepts. And so what would happen with the beads is if it wasn't going from a more denser medium and bending towards the normal, it would just go this way. And so it's not turning around to come straight back to you. And same with here, from a denser to a lighter medium, if it wasn't refracting away from the normal, it would go this way. And so you're getting a lot more turn from the bead, and then you're getting the reflection here as well with a concave versus a convex, which would disperse it out more rather than turn it in. So the concave mirror is working to turn it around, and the less to more dense and then to less dense is also all working towards turning that beam around. And so if you go to the PhET simulation, you can see that quite clearly. So if you go here, now, as you can see, not all light always refracts. There's always some reflection. So we're looking at the reflection here, specifically when it comes off the mirror. So when it comes off here is the one we care about. We'll just ignore every other one. And can you see that as you move this around, it's really going nowhere near where the source is. And if I spin it this way, it's just going up over there, and it's going very easily way over here. Okay, but if I use a concave mirror, you can see it's much, much better. It's not going so far away. We're only looking at this bit here and this bit here. And if I turn it again, it's helping it turn inwards a lot better. So we're going to pretend that there's reflection going on there, and then we've got the glass bead. And so you can see the glass bead, as I said before, it turns it, so it's hitting here. Instead of going out here, it's turning it in a bit. Instead of going out there, it's turning it in a bit again. And so you can see, and then we're not looking at this, we're looking at the reflection. This one to be refraction, and reflection here. So you can see that the beam is almost, well, pretty much, especially the further away you go, is pretty much coming in at the same direction that it left. And if I turn it, it's doing that as well. So we're looking at, make sure we're looking at the right one. We're looking at the one that comes in. So we're looking at this one here all the time. And the further out you go, the better it gets. Okay, so you can see that the bead and the reflection all work towards turning that thing to get the light to go back to the source. And while I'm here, so when the sun's behind you and you can see that and then there's rain in front of you, the light bounces like this, and so you can see the rainbow there. And so if you just go to white light, that is white light. If I go to a red beam, you can see if I put this one at the 60 and I change it to purple, you see it'll go less than 60. See, it moves down. That would have been a much better rainbow if I could get that to pause. And so that's why you can see a rainbow, all right? Because the light, red doesn't split up, doesn't refract as much as purple, and the light comes back straight into you. A lot like what we're retrorefraction, really. This is sort of retrorefraction. A rainbow. Should look that one up. Okay, so apart from that, so the application is also how rainbows work. There's also an environmental one. They love environmental ones. And so instead of angling your awnings so that it gets blocked in the summer, and when the winter sun's lower, the sun gets in when you want it to. So it warms your house in the winter and keeps it cool in the summer. You could cover the whole house with this retroreflective material and have at the right angle, have it reflecting. So if it's too high in the sky, it's a summer sun and it's too hot, it reflects, goes back out to space, and then when it's lower and colder, they have that part absorbent, and so that will retroreflection to save energy. Okay.